Hey everyone, welcome back to the channel. So have you ever wondered how speech AI can tell the difference between bat and pat or ship and chip? That tiny difference, that's called a phoneme. And in this video, we're going to break down what phonemes are, how humans and AI process them, how they help AI understand accents and emotions, and why they're absolutely essential for speech recognition and voice synthesis. So by the end of the video, you'll see how something as small as a single sound forms the foundation of how machines understand us. A phoneme is the smallest sound unit in a language that can change meaning. So for example, bit versus beat. One vowel sound changes, and so does the word. Cat versus cut, same thing. So English has around 44 phonemes, and that's depending on the accent, but other languages have more or fewer. For example, Hawaiian has only 13 phonemes, but Ta, a language from Southern Africa, has over 100. So the number of phonemes in a language is part of what makes it sound distinct, and that's exactly why AI models need to learn them so carefully. Here's a key thing. Phonemes aren't the same as letters. For example, the word phone has 5 letters, but only 3 phonemes. That PH combo represents a single sound. Humans learn this naturally, but for AI, this data is pre-processing gold. Speech AI must learn to map acoustic patterns or sound waves to phoneme units, not letters or words. Otherwise, it would constantly misinterpret the same sound into different spellings. When you speak, AI breaks your voice into tiny time slices, as short as 10 to 25 milliseconds, and then it analyzes features like pitch, energy, formants, which are those resonant frequencies in your voice, and timing. And then the model uses these acoustic features to predict which phonemes you're producing. It's kind of like how your brain fills in missing sounds in a noisy room. The AI is constantly guessing which phoneme fits best based on patterns it's already learned. So systems like Azure Speech are trained on thousands of hours of speech in multiple languages. And these data sets teach the model what each phoneme sounds like in context and how it varies across speakers. So for example, the phoneme T sounds slightly different in top, stop, and button, yet to your brain and to AI, those are still the same phoneme, but that's because both humans and machines normalize variations using context and probability. So here's where it gets fun. Phonemes also explain why accents exist. An American English speaker might pronounce water as water, while a British English speaker might say water, and you can see the difference of the phonemes. Different accents may use slightly different vowel phonemes, but the underlying phoneme pattern, the structure, it stays recognizable. And that's why AI can understand multiple accents, because it's not memorizing your voice, it's identifying phoneme patterns. So phonemes aren't just for speech recognition, they're also just as important for text-to-speech. When Azure text-to-speech generates a voice, it first converts text into phonemes. Then it uses deep neural networks to produce audio that matches natural human speech patterns. If you've ever heard a voice that sounds robotic, that's usually because it's not handling phoneme transitions, the smooth blending between sounds very well. The better a system models those transitions, the more natural and human it sounds. Now here's where it gets even deeper. Phonemes carry emotion too. Your tone, pitch, and pacing can make the same phoneme sound completely different emotionally. A good example of that is really. So you can say really, or you can say really, or you can say really. AI models trained on expressive speech data learn to interpret and replicate those emotional cues, and it all starts with accurate phoneme recognition. So all of this we just talked about, phonemes, context, and emotion, they come together and they allow you to make real-world use cases. And some of these use cases would include accessibility tools for reading text naturally for people with low vision, multilingual translation for customer service, voice cloning for creators and brands, and also cross-language learning tools for ESL learners. Azure Speech, they use a combination of phoneme-based modeling as well as neural acoustic modeling to make all of these use cases possible. So phonemes might seem tiny, but they're the Lego bricks of speech understanding. Without them, AI couldn't decode what we say, replicate how we sound, or adapt to the endless variety of human voices. If you found this breakdown helpful, give it a thumbs up and subscribe for more videos on how speech AI really hears us. Thanks for watching, and we'll see you on the next one.